Greetings of the day. Welcome to another session of Grade 9 Mathematics. Dear students, we are going to deal today with Chapter 14 Statistics. In this second part of the Chapter 14, we shall be discussing the solutions to NCERT exercise 14.2 and 14.3. Dear students, we shall be using the concept of frequency distribution table using tally marks, and the construction of bar graph to these exercises. Let us quickly get to the first question of NCERT exercise 14.2. Exercise 14.2, question number 1. The blood groups of 30 students of class 8 are recorded as follows. So the blood groups are given as A, B, O, O, AB, O, A, O, B, A, and so on. So there are in total of 30 students' blood groups. Now, we have been asked to represent this data in the form of a frequency distribution table and then find out which is the most common and which is the rarest of the blood group among the students. Now, as you could see part of the solution, all that I first did is identify the different type of blood groups given in the question. So the different type of blood groups are A, B, O, and AB. And then all that I did is do the process of tally marking, which we have learned in our previous grades also. So as you could see over here, out of the 30 students, there are 9 students having blood group A, 6 students having blood group B, 12 students having blood group O, and 3 students having blood group AB. And you may please verify this again by summing up the number of students in the last column. Yes, it has to be 30 because this is a data of 30 students. Now from this, we can easily conclude which is the most common blood group. As you can see, there are 12 number of students having the O blood group. Therefore, the most common blood group will be the blood group with the highest frequency, which is the O blood group. And the rarest blood group will be the blood group with the lowest frequency. And as you can see from the frequency distribution table, the blood group with the lowest frequency is the blood group AB. Wasn't that simple? Yes. Indeed, this is what you have to do in the entire exercise, in all the 9 sums of exercise 14.2, making frequency distribution table using tally marks. Let us quickly then get to the second question. So the second question says, the distance in kilometer of 40 engineers from their residence to their place of work were found as follows. So the distances are given in kilometers as 5 kilometer, 3 kilometer, 10 kilometer, 20 kilometer, 25 kilometer, and so on. So we have the distance of 40 different engineers, the distance of these engineers between the place of work and the residence. Now we have been asked to construct here a grouped frequency distribution table. My dear class, we have been asked to make a grouped frequency distribution table with the class size 5 using the data given above, taking the first interval as 0 to 5, wherein 5 is not included. And then we have to conclude what are the main features that we observe from the tabular representation. Now, whenever you are going to make a grouped frequency distribution table, my dear students, the first thing that you have to do is observe from the data the minimum and the maximum values. Here in the observation, the minimum and the maximum values are 2 and 32 respectively. And as suggested, we'll begin with taking the first interval, the class interval, as 0 to 5. Now, since it is mentioned in the question that 5 does not have to be included, it clearly indicates that we have to have a continuous class interval. So 0 to 5 becomes a first class, the next will become 5 to 10, the next will be 10 to 15, 15 to 20, 20 to 25, 25 to 30, and 30 to 35 will be the last class. Why is 30 to 35 the last class? Because the highest or the maximum value given in the data is 32. So that will surely come up with the class interval 30 to 35. Hence, we'll end up with the last class as 30 to 35. Now, let us start with the tally marks. Where would the first number 5 come? Will it come in 0 to 5 or will it come in 5 to 10? My dear students, when you have got a number that if you think can come up in 0 to 5 or 5 to 10, since this is continuous class, it will always go to the higher class. It is always go to the higher class. So 5 will be included in the class interval 5 to 10. Now the next number is 3. 3 will for surely come into the class interval 0 to 5. And so on, we shall proceed with putting the tally marks as per the data that is given in the question. And you could find over here that there are 5 engineers whose distance between the workplace and their residence is between 0 to 5. There are 11 engineers in the class 5 to 10 kilometers. There are 11 engineers again in the class 10 to 15. There are 9 engineers in the class 15 to 20 and so on. And as I did mention in the last question, please ensure that you total up the last column, that is the frequency, the number of engineers, which should be equal to the number of data or the number of distances that are given over here. Now, let us get to the second part of this question. Once you have made the frequency distribution table, we can easily observe from the table that the frequencies of class intervals 5 to 10 and 10 to 15 are equal. That is 11 each. It shows that maximum number of engineers have their residences at 5 to 15 kilometers away from the workplace. Isn't it? You can also see that frequencies of the class intervals 20 to 25 and 25 to 30 are also equal and they are the least, that is 1 each. It shows that the minimum number of engineers have their residence at a distance of 20 to 30 kilometers away from the workplace. So these were the 2 observations that we have made after making the grouped frequency distribution table from the data. Wasn't that easy? Indeed it was. Let's get to question number 3. Now, question number 3 is another easy one, which says the relative humidity in percentage of a certain city for a month of 30 days is as follows. So the relative humidity is being given in percentage of in the first day say it is 98.1%, the second day it is 98.6, the third day it is 99.2 and so on. The percentage is given for 30 different days. Now, as part of the question, if you could see, we have been asked to make a grouped frequency distribution table with classes 84 to 86, 86 to 88 and so on. The question itself, you could see, we are expected to make a grouped frequency distribution table with continuous classes. Also, we have been asked to find which month or season do we think the data is about, and in the third part, what is the range of this data. Now, as I said yesterday, or in the last question itself, we have to first find the lowest value in the observation, which is 84.9, and also the highest value of the observation, which is 99.2. Now, with this, we can start making the group frequency distribution table starting from the class interval 84 to 86, because the lowest value, which is 84.9, will surely come up in the group 84 to 86. Now, as you can see over here, I made a grouped frequency distribution table using the data. So 84 to 86, we have only 1 tally mark, so the frequency is 1. And if we could see, in the class interval 92 to 94 and in the class interval 96 to 98, we have the maximum days, that is 7 each. So out of the 30, 14 days you could see over here has humidity in the range of 90 to 94 or say 96 to 98. Now, since the relative humidity is high during the rainy season, so we can predict that the data appears to be taken in the rainy season. The last part of this question was to find the range. Now, we have learned this in our previous class that range is actually the difference between the highest observation and the lowest observation, which we have initially found out in this case. So the highest observation was from the data, if you could see, is the number 99.2 and the lowest observation is 84.9. Find the difference between them? Yes, the answer is 14.3. Therefore, we can conclude that the range of this particular data, that is of 30 days of humidity in percentage, the range is 14.3. Now, let us get to the next question. Again, as you could see, the height of 50 students measured to the nearest centimeters have been given. We are supposed to represent this in the form of a grouped frequency distribution table with the class intervals, again mentioned as 160 to 165, 165 to 170, and so on. And we have been asked to conclude about the heights once we create the grouped frequency distribution table. Now, we'll proceed with the same thing. Get the highest value from the observation, that is 173. The lowest value from the observation, which is 150. And then let us decide which would be the first class interval. So we can start with 150 to 155. Because as it is mentioned in the question, the class height has to be 5. Yes, so we'll begin with 150 to 155. So 150 will already be part of this and followed by the next class intervals such as 155 to 160, 160 to 165 and so on till 170 to 175. As the largest or the highest value in the observation is 173, which will come up in the class interval 170 to 175. Go forward with preparing a tally marks. Get the frequencies correct, cross-check with the total, and here you are with your group frequency distribution table. Now, as we have been asked in the question, what can we conclude about the height from the table? We can conclude that more than 50% of the students are shorter than the height of 165 centimeter. If you could see over here, less than 165, we have almost 35 students. 12 plus 9 plus 14. 35 students whose height is shorter than 165 centimeter. So this is a conclusion from this data. Now, let us get to the next question, which says, a study was conducted to find the concentration of sulfur dioxide in the air in parts per million of a certain city. Now, the given data was obtained for 30 days, which is as follows given over here. So this is about the concentration of sulfur dioxide, which was recorded in a certain city. The data, as you could see, is 0.03 parts per million, 0.08, 0.08, 0.09, and so on. In this question, we have been asked to make a grouped frequency table for the data with class intervals 0 to 0, 0.00 to 0.04, 0.04 to 0.08, and so on. And then we also have been asked to find for how many days was a concentration of sulfur dioxide more than 0.11 parts per million. Now we'll proceed with the same process. That is, first we'll find the lowest and the highest value in the observation. Now, the lowest value in the observation is 0.01 and the highest value in the observation is 0.22. Hence, we can come up with the conclusion that the class intervals can be 0.002, 0.04, and so on as mentioned in the question. Now, if you look at the group frequency distribution table, we get the observations in the form like 0.00 to 0.04. The concentration was so for 4 number of days. And so on. From the table, you'll make up the group frequency distribution table using the process of tally marks. And you can conclude that the concentration of sulfur dioxide was more than 0.11 parts per million ppm for 8 days. Yes, so it would be the bottom 3, 2 plus 4 plus 2, a total of 8 days. So again, a very simple group frequency distribution table using tally marks has been made over here. Similarly, we can go with question number 6, which is again mentioned wherein there are 3 coins which are tossed 30 times simultaneously. Each time the number of heads occurring was noted down. So in the first instance, 0 heads, that means all were tails. In the second instance, 1 head, and then 2 heads. The fourth instance of the 2 heads, and so on. And we have been asked to just make a frequency distribution table. Yes. So here the observations are very simple. Observation values are either 0 or say 1 or say 2 or 3. So the number of heads occurring is 0, 1, 2 or 3. Here we are not been asked to make a group frequency distribution table. And hence we can directly go with the tally mark process and get the frequency for the given question. Yes, so if you could see, how many times did 0 heads occur? 6 times. How many times did 1 head occur? 10 times. And how many times did 2 heads occur? 9 times. And then it was 5 times when the number of heads on all the 3 coins were all heads. Yes, I hope you are clear with the solution to this particular question number 6. You must have observed that all that we have done is the same process in the last 6 questions, which we shall continue with question number 7 also. Now, question number 7 says, the value of pi up to 50 decimal places is given below. So, the value of pi is given as 3.14159265358979 and so on up till 50 decimal places. Now, we have been asked to make a frequency distribution table of the digits from 0 to 9 after the decimal point. So, we have been asked to make a data wherein to show that how many times did the digit 0 or say 1 or up till the digits 9 come up after the decimal places. I repeat again, after the decimal point. Okay. So as you could see, as part of the solution, I have made a frequency distribution table using the process of tally marks. And you can observe over here that the digit that comes maximum times, that is 8 times, is the digit 3. Okay. And you can sum up the frequency column, which should be equal to the data that we have, that is 50 decimal places. Now, can you conclude which is the most and the least frequently occurring digits? The most frequently occurring digits, as we said, is the digit 3 as well as the digit 9. Both of them occur 8 times each. And which is the least frequently occurring digit? The digit 0, which occurs only 2 times. Now, let us get to question number 8. Here too, 30 children were asked about the number of hours they have watched TV programs, and the number of hours are given below as 1 hour, 6, 2, 3, 5 hours, 12 hours, 5 hours, 8 hours, and so on. We have been asked to make a frequency distribution table with the class width 5 and one of the class intervals as 5 to 10. And then conclude from the question that how many children watch television for 15 or more hours a week. We proceed with the same process, get the smallest value as well as the highest value from the observation, come up with which should be the smallest class interval in according to the lowest value of the observation, as well as come up with the highest class interval that should be there, keeping in mind the highest value of the observation. Now, as you can see over here, my class intervals are 0 to 5, 5 to 10, 10 to 15, and 15 to 20. And I just proceed with putting up the tally mark process. And what I get is that 0 to 5 hours, there are 10 children. 5 to 10 hours of watching of TV, I have 13 children. 10 to 15 hours of watching of TV, I have 5 children. And then 15 to 20 hours of watching of TV, I have 2 children. Now, if the question is, how many children watch television for 15 or more than 15 hours? The last row, that is the number of hours 15 to 20, and you can find that the number of children in this case is just 2. I hope this is clear to everyone. Very similar to what we did with the previous 7 questions. The same you shall do with question number 9 also. Here, you have been asked to take a class interval of size 0.5. So as you could see, I just went with finding the lowest value of the observation, which is 2.2, the highest value of the observation, which is 4.6, and then come up with my class intervals. Please have a look at the solution, very similar to the process that we did for the previous 8 questions. My dear students, I hope now we have understood all the 9 solutions to the questions of exercise 14.2. All that we did was make frequency distribution table, or say the grouped frequency distribution table with the class intervals or the class sizes as mentioned in the question. If that's the case, let's quickly get to the 3 more questions from exercise 14.3, wherein you are supposed to make bar graphs. So while you solve this sum, please ensure you have a graph paper ready with you with the x and the y axis line drawn properly. Now, if you could see, all that we are supposed to do is plot a bar graph. Let's read the question. A survey conducted by an organization for the cause of illness and death among the women between the ages 15 to 44 years worldwide has been given below. Now, because of reproductive health conditions, the fertility rate among the females happens to be 31.8%. Neuropsychiatric conditions, the percentage of fertility is 25.4. Because of some injuries, the death among or the illness among the women have been 12.4%, and so on. We have been asked to represent this information above graphically, and more specifically in the form of a bar graph, which is part of your syllabus for this particular academic year. And after that, we have been asked to find which condition is a major cause. Even without a graph, you can easily conclude that since the reproductive health conditions actually go for 31.8% of the causes for the fertility rate, we can easily say that reproductive health condition is a major cause of women's health and death worldwide. Also, we have been asked to find out, with the help of teacher, any 2 factors which may play a major role in the cause of death and illness among women, apart from above being the major causes. Now, as you could see, all that I did was take a graph paper. On the x-axis, I'll represent the causes, and on the y-axis, I'll represent the percentage. So, as we had very much discussed, what a bar graph looks like, they are vertical rectangles, yes, of equal size, but that is same width but varying height as per the data. This is all that you have to do, and after that We have to find two more factors which could be responsible. It could be education and poor background. So as you could see over here, I have plotted a bar graph with very much care taken in the size of the units on the y-axis with a gap of 5. So 0 is the first line on the y-axis, then I have 5, 10, 50, 20, 25. Now this has to be consistent, very much that we used to do in our previous grades. Let us get to the second question. Again, we have a data wherein the number of girls per thousand boys in different sections of the Indian society is given below. And you can easily read out from the table that was in scheduled caste, we have 940 girls per thousand boys, and so on. And we have been asked to represent the information above in a bar graph. Yes, let's do that quickly. Take a bar graph and represent the data on a bar graph. Now, as you could see, the numbers are in the, has a variation with 10. So the lowest number is 910 and the highest number is 970. And others, if you could see, the numbers are like 920, 930, 40, 70. Yeah. So what you can do is when you construct a bar graph on the y-axis, you can keep a gap of 10. As over here, I had plenty of space, so I began with the number 880, 890, 900. Now this has to be uniform. Okay, the height of the boxes have to be uniform. Now, as you could see from the graph itself, we have plotted that the number of girls in scheduled caste is 940, in scheduled tribe is 970, in non-SC/ST it is 920, in backward district it is 950, and so on. All that I did is make a bar graph from the data that is given in the question. From this we can conclude that the number of girls per thousand boys is maximum in scheduled tribe section, whereas it is minimum in urban section. Give a thought of this and try to find out why is this happening in urban section wherein we have less number of girls per thousand boys. Apart from that, I hope you have understood the solution to question number 2, how to make a bar graph, very much that we have been doing in grade 7 as well as grade 8, nothing much of a difference. Coming to the last question that we are supposed to do, question number 3, wherein given below are the seats which are won by different political parties in the polling outcome of a state assembly elections. As you could see, say political party A has won 75 seats, political party B has won 55 seats, political party C has won 37, party D has won 29 seats, party E has won 10, party F has won 37 seats. And as part of the question, we are asked to draw a bar graph to represent these polling results. Now, if you could see, we don't have a uniform gap, like one number is 75, 55, and then have 37. So we cannot say that we have a uniformity of 5, tables of 5 coming up. No, that isn't the case. So I will keep it very simple. I'll keep the height of my boxes as 10 units. So 0 to 10, 10 to 20, 20, 30, 40, 50, 60, 70. Or should I go for 80? I'll go for 80 because the highest data is 75. So as you could see over here, my x-axis has the details of the political party. My y-axis has the data with respect to the seats won. Now, can you guess out, not even guess out, can you conclude from the graph which political party has won the maximum number of seats? Yes, the political party with the highest rectangle, which is it? Party A. So party A has won the maximum number of seats. Can you make out which is a party which has the least number of seats? Yes, if you could see the rectangle, which is the lowest in height, that is the party E has won the minimum number of seats. My dear students, I hope you have understood all the different concepts of frequency distribution table as well as bar graphs, which have been discussed even in the first part of the video of this chapter. I hope you all have understood the solutions to exercise 14.2 and the solutions of the first three questions of exercise 14.3. On this note, we'll end up this part of the video. Take care of yourself until we meet next time with another session of Grade 9 Mathematics. Thank you.